Hello there. In this video we're going to continue our discussion of properties of lines, but in this video only we're going to focus primarily on horizontal and vertical lines. So remember, a horizontal line in terms of the XY plane is any line that is something like this, pretty much flat, doesn't increase or decrease as you proceed from left to right. And what we mean by a vertical line is any number or any line that pretty much represents something like this, where it pretty much goes all the way up and all the way down, but it does not go left or right with respect to x and y in that orientation. So in this video we're going to be exploring the equations of vertical and horizontal lines and discussing a couple side properties as well. So let's begin by trying to see if we can derive the equation of a horizontal line. So let's begin. So example 1. So I'm going to draw a coordinate plane, and I'm going to draw a horizontal line such that it crosses this point here at 0, 5. So if it's horizontal at 0, 5, then that means the next point that's a pretty point probably would be 1, 5. The next point would be 2, 5. Over here would be negative 1, 5, negative 2, 5. And no matter what point you pick on this line, the y value is always going to be 5. So if we look at a table of values, for example, so if we pick a bunch of points, negative 3, negative 2, negative 1, 0, 1, 2, and 3, then you're always going to get 5 as the output for that table of values. So regardless of the value you have, there's always one thing in common, namely y is going to be equal to 5. So y is equal to 5 will be the equation of this horizontal line. So, as another example, suppose I say graph the equation y is equal to negative 2. So similar to the example above, no matter what x values you choose, the y value is always going to be negative 2. So for example, if this is negative 2, that's negative 2, that's negative 2, that's negative 2, and so on. So let's label our axes as well, x and y. So if we connect all these points, then this is the graph of that line. And again, if you choose any points on the table of values, say negative 3, negative 2, negative 1, 0, 1, 2, and 3, you'll always get negative 2 as the output of that relation. So now let's take a look at the vertical line case. So the vertical line case, so let's pick a point somewhere. Let's choose this line. So let's choose this point to be, say, negative 3, 0. So if this is a vertical line, that means the x-coordinate shouldn't change. So this is going to be negative 3, 1, negative 3, 2. Down here should be negative 3, negative 1, negative 3, negative 2, and so on. So if we were to look at a table of values, for example, so we have a bunch of y values, notice here, right? So we have, say, negative 3, negative 2, negative 1, 0, 1, 2, and 3 for various y values, but we also have negative 3 for all of the corresponding x values. So clearly, this is not a function. So that's one obvious property that we can justify here. So vertical lines are not functions of x, assuming that this is the x-axis and this is the y-axis, and all of the x values for a vertical line would be the same exact value. So the equation of this vertical line, so equation is going to be x is equal to negative 3. So as an example, suppose I say graph the line, or graph x is equal to 7. So similar as before, x is always going to be a 7 regardless of the y value for which you choose. So let's find 7 over here. So 1, 2, 3, 4, 5, 6, 7. Let's draw a vertical line there. Let's assume that this is the x-axis and this is the y-axis. So this point right here is going to be 7, 0. This is going to be 7, 1, 7, 2, 7, -1, 7, -2. So clearly, this is going to be the graph of that vertical line. So one important property that you should be able to come up away from this is if the equation has x only, say no exponents, nothing crazy looking, then the graph is a vertical line. And if the equation has y only, no special things, then the graph is a horizontal line. And there's another property that you may be able to justify on your own. So the only line that is not a function of x is a vertical line. So example 5. Consider the equation 3y minus 5 is equal to 3. So this is definitely a relation between y and a bunch of numbers. So what type of graph would this relation be? So this relation, so this only has y in it. There's no y squareds, no square roots of y's, no anything else, nothing special. Just numbers, an equation with equal signs and y only. So this is going to be a horizontal line. So what is it equal to? Usually horizontal lines are written as y equals number. So let's see if we can figure out what that number should be. So 3y minus 5 is equal to 3. So let's solve this basic equation. So let's add 5 to both sides of this equation. So 3y is equal to 8. And now let's divide both sides by 3. So y is equal to 8/3. So I want to sketch the graph of this relation here. It's the same as sketching the graph of that relation. They are the same exact relation, just slightly rewritten algebraically. So this is x and this is y. So 8/3 is slightly less than 9/3, which is 3. So should be, I don't know, somewhere around there approximately. So this is going to be 0, 8/3. So that's the graph of that relation. Let's do another example. So example 6. So consider the equation 3 minus 2x is equal to 7. So again, this is a relation, R, I'm going to call it. So what is the graph of this relation? So this relation only has x in it, nothing special, no dividing by x, no square roots of x, no x squares, no nothing, no none of that. So this is going to be a vertical line. But again, typically vertical lines are written in normal form as just x equals just a single number. So let's see if we can modify this relation algebraically into something that is a little bit more familiar to us. So I'm going to begin by subtracting both sides by 3. So I'm going to get negative 2x is equal to 4. Then I'm going to divide both sides by negative 2. So those will cancel. So x is going to be equal to negative 2. So the relation that I had all the way up here and this relation down here is going to have the same exact graph. So let this be the x-axis and this be the y-axis. And let's draft negative 2 here. So this is going to be the graph of my relation R, where this point right here is negative 2, 0. So this is just some basics of equations of lines, namely in particular two vertical lines and horizontal lines. So definitely two basic principles that you should know. If it has x only, and I'm not talking about x squareds and x cubes and so forth, then it is going to be a vertical line. And if you have a relation written algebraically that only has y only, and I mean like just simply y, no y squared, no square root of y terms, no x times y's, and nothing fancy like that, then this is going to be the graph of a horizontal line. And there's lots of other things that are associated to these particular observations that are associated to solving equations in particular, but we'll talk about them at a later time. But this is just some basics on horizontal and vertical lines.